Hello and welcome to another video. In this video we're going to be working on maximum matrix sum, and I've done this one before, so I'm just going to do a review of this one. So in this one you have an n by n integer matrix, and you can do the following number of operation any number of times. Choose two adjacent elements of the matrix and multiply them by -1. Two elements are considered adjacent if they share a border, so it has to be like left, right, up, or down. And your goal is to maximize the sum of the matrix. Return the maximum sum. So in this first example, you can do these two operations and then you get everything to be a 1. And in the second example, you just turn these positive and then you have this. So for problems like this where you can do some operation, the thing you kind of really want to do is you want to like get a matrix, try to play around with it and see what observation you can make. And with this, basically if you find one observation, then the problem is super easy, but it's not super hard to find. Or it's not super easy to find, I guess. I guess this example does kind of show it to you, though. Sort of. It shows you part of it, at least. So these two examples show you that if you have adjacent elements that are negative, you can just make them into 0. Or into positive elements, right? And this one shows you that if you have diagonal elements that are negative, you can also change both of those without changing the rest. So there's two operations you can do. You have adjacent elements, which is like left, right, up, down. You can flip both without changing anything else. And this first example shows you that if you have diagonal elements, you can flip both without changing anything else. And the real kind of key to solving this problem really easily is, let's say we do have some big matrix. I'm not going to draw any numbers. But the idea is, if I have two elements and I swap them and one is positive and one is negative, then I can flip one and not change the other. So like, let's say this is the only negative element I have in my table. The main observation you're going to need to take away is I can then make anything else in my table negative and flip this. So like basically if I want to flip this element, and this element, there is an order of operations I can do that. So there's a bunch of ways, but one of the ways would be like, this is operation 1, this is operation 2, and then every element that's flipped twice has its original value, right? So this is flipped twice, so this will be original. Operation 3, operation 4, operation 5, operation 6. So you can see like I made some path that goes from one to the other, and it's always possible in a matrix. You can always make some path. Every element gets flipped twice except for this one and this one. And so now these two get flipped. So everything else stays the same, but these two actually flip. So this tells you that if I have some negative number that's really big and a small positive number, I'm just going to want to take my negative number, make that positive, and find the smallest number in the table to make negative, right? So let's say, like I said, let's say this is the biggest negative number, right? Some negative infinity, whatever. And this number is really small, positive. All I have to do is just, there's always going to be a path because it's a matrix from this to this. Just any path works. This, it doesn't really matter. That everything on this path will get flipped twice, right? So this gets flipped once, twice, 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 once. And anything that gets flipped twice stays the same. But now what ends up happening is this negative infinity turns into positive infinity. And then this turns into this negative very small number. So from that observation, you can basically figure out if I have just one negative element, I just want to figure out like what's the smallest number in my table and make that negative, and take my negative element and make it positive, right? So if I have a bunch of numbers and there's only one negative element, I would just take my negative element, make it positive, find the smallest other element and make it negative. Now if my negative element is already the smallest element, then that's fine. So you basically take the absolute value of every value, and then whatever is the smallest, that's the one you're going to want to take and make it negative. So that's if I just have one negative number. Now, what if I have two negative numbers? So let's say this is negative and this is negative. Well, from what we established before is you can just, there's a way to always flip two numbers. So I can just make some path that flips this to positive and this to positive. And then my whole table's positive, and that's the maximum I can get. So with 2 numbers, you can just make them both positive. What about if I have 3 negative numbers? So with 3 negative numbers, I can do a bunch of different things, but one thing I could do is I can make like 2 of them positive, right? And then leave the next one negative. But really what I want to do is I still want to do this thing where I find what's the smallest number in this whole table, and let's say it's over here. Then I can just say like, okay, well, I'll just take 2 of my negatives and make a path. That will get rid of both of those. Now those are both positive, and take the last one and do this path thing, where now this number will become negative and this will become positive. So essentially the problem is pretty simple, and it's basically just find smallest number in table and then count number of negatives. If that number mod 2 is 0, if I have an even number of negatives, I can just take every pair and make them positive, and then my sum is just everything. If that number is negative, or not negative, if that number is not like even, then I'm just going to pair them all up, then I'll have 1 left, and then I will flip the smallest positive number in my table. And that's basically all you need to do. So hopefully that makes sense. You just find the smallest number, and you can calculate the sum as you go. Just take the absolute value of every number, add it all together, and then just check for this condition. If this is 0, then you're done because everything will be negative. If it's not, then what you have to do is you have to find the smallest number and you have to subtract. So you have your sum, and you have to subtract 2 times that sum, 2 times that number. Because when you originally did the sum, you did the addition of everything in the whole table. So that means if this is x, right, you would say like a bunch of other numbers plus x. But if you want to subtract that number, if you just subtract that x, then that's basically like you didn't subtract that number, you just didn't add it. So to subtract it, you would subtract the x again. So if this number was like 2 and your total sum without the 2 was like 60, or with the 2 was 60, then you're going to want to subtract 4 because you added 2 to get 60. So now to subtract 2, you actually need to subtract 2 once to get the sum without this number, and then to actually subtract it, you need to subtract it again. So that's basically it. You just recognize this operation that because I can do these things, I can flip any pair of negatives into a positive, and therefore I can always just pick the smallest number and make that negative. So you're always going to have either one negative number or 0, depending on how many pairs you have. And I do think it's not super simple to come up with, but once you figure it out, the actual code's like pretty easy. So we can take a look. So we basically just keep track of the smallest value we have and the number of negatives. Then we just keep adding every single value, and we keep minimizing the smallest value. And then if the number is negative, we just increment count negatives. And then we just check, do we have an even or odd number of negatives? If we have an odd number of negatives, we do result minus 2 times the smallest number, because that one needs to get subtracted twice from what I shown before. And if you have an even number of negatives, then your sum, everything just becomes positive. So then it's just your total result. So I'm also not super sure why this has such bad runtime, because it's basically like as fast as it gets. I guess maybe I can like not use min and abs and stuff so much and clean it up a little, but yeah, this is basically the optimal solution. I think it should just be like nm or n squared or whatever it is. Yeah, n squared. I mean, you have to go through the matrix, not much you can do there. So this is like, I guess the better way to say is like nm usually for a matrix, where it's like you go through the matrix once, or n squared, where n is the side of the matrix, either one. And space is O1, because we're just keeping track of 2 things here. I didn't look at this before, so I'm curious what happens here. Journey something. Let's see. Yeah, so this is kind of like the same thing. So basically, you can figure out from this thing, I can take any pair of negatives and make them 0, or positives, or I can take any one negative and change any positive to a negative instead. So hopefully this is helpful. If it was, please like the video and subscribe to the channel, and I'll see you in the next one. Thanks for watching.